I thought I'd show you this really nice graph of, or this map of soil organic matter in the United States. This was from University of Wisconsin website. But you can see where it is that we really have increased organic matter, high amounts of organic matter, and you can see it's right there in the Midwest. We've got some upper Midwest is where we find a lot of organic matter. Florida has a lot of organic matter. In the Northwest we have some. But you should maybe ask yourself why it is that we have organic matter in these particular areas, and these brown areas as well. Why the higher organic matter? Why is there this line right here in organic matter? Or why is there low organic matter in a place that we know has high biological activity and theoretically should have, if you have higher biological activity, that would probably yield you more organic material. And so there's a lot of things to think about. The climate that might yield itself to more organic matter, what kind of plant material we find on the surface there. If you've ever been to Iowa, you know that the soils there are very, very dark, full of organic matter. Out here where we are, we do have places that have organic matter, but this is a really interesting graph to just think about why that may or may not be, why we may or may not have high organic matter areas. We'll go ahead and put that away for now. In Figure 11.7 in your book, we have this diagram of the types of organic matter that exist in soil. We have, of course, organic material in the living organisms, in the biomass. We also have what we call identifiable dead tissue, detritus. Let me show you a picture of that here. So there's some plant root material, mainly, maybe some old plant material that's fallen from the limbs and things like that, and that's what we would consider detritus. Then we have this this humus material. We can't really identify it as having its source in a particular particular biology, like a grass leaf or a grass root or a forb or anything like that. It's not really identifiable. In this material, we have two sorts of humus material breaking up. Non-humic substances. So these are usually materials that result from breaking down organic matter, or even breaking down further humus, some chemicals that come out of that process. And then we have the actual humic substances, which are really important. These are the ones that are really giving us the colloidal properties that we've discussed before. This picture right here, I just want to show you what that actually looks like. This picture right here shows us some of those humic substances. So you can see, what I really want to point out is the fact that these are sort of shapeless. They're not like a clay mineral in that they're recurring sheets of elements. These are what we call amorphous. They don't have a reoccurring shape, and sometimes they're spherical, but there's a lot of little nooks and crannies in there. If we were to break it down even further, you would see something similar to this. Now, this is what we think organic matter at a very, very small scale looks like, and you can see the formation of it with this sort of ball and stick model there, the carbon change and things like that. But the amorphous shape, the non-recurring shape of this material gives us some really great properties. Water holding capacity, high surface area because of that water holding capacity, the ability to hold nutrients, because we've learned before that these COOH areas on the edge here can, depending on the pH, provide us with anion or cation exchange capacity. But I wanted to show you some of what these substances look like to give you a better feel as we're discussing organic matter, what we're actually talking about with these materials.